$1 trillion. That's not a prediction. That's what Jensen Huang told a packed room in San Jose this week. NVIDIA can see $1 trillion in AI chip orders through 2027. Last year, that number was $500 billion. It doubled in 12 months. And that's not even the most interesting thing he said. In the next 7 minutes, I'm going to break down the 5 biggest announcements from NVIDIA GTC 26, what they actually mean, and why this keynote might be the most important tech event of the year so far. Let's go. Chapter 1. The $1 trillion claim. Here's some context. 3 years ago, NVIDIA's total annual revenue was about $27 billion. Then, AI happened. Data center revenue jumped from $15 billion to $47 billion in a single year. By late 2025, NVIDIA was generating over $68 billion in a single quarter. That's more than its entire annual revenue just 3 years earlier. Now, Jensen is saying he sees $1 trillion in combined orders for Blackwell and Vera Rubin chips through 2027. The reason? He says we've hit what he calls the inference inflection point. Training AI models was the first wave. Now the money is in running them. Every ChatGPT query, every AI agent, every coding assistant, that's inference. And it's growing exponentially. Quick thing, if you're watching this and you're not subscribed yet, now would be a good time. I break down one major AI story every week with real numbers, no hype. Just hit subscribe so you don't miss the next one. His exact quote, "We have reached that moment of inflection. The inference inflection has arrived." And the numbers back it up. Over 90% of NVIDIA's revenue now comes from AI data centers. Not gaming, not graphics, AI.
Chapter 2, Vera Rubin, the new chip platform. The star of the show was Vera Rubin, named after the astronomer who proved the existence of dark matter. And this chip platform is NVIDIA's next major architecture after Blackwell. Here's what makes it matter. The Vera Rubin GPU delivers 5 times the performance in the new NVFP4 format compared to Blackwell, 3 times faster in standard FP8 operations. But the real headline is the system-level numbers. A single Vera Rubin NVL72 rack can output 700 million tokens per second. The previous generation, 22 million from an entire 1 gigawatt data center. That's a 350 times improvement in 2 years. Moore's law would have given you about 1.5x in the same period. NVIDIA also introduced the Vera CPU alongside it. This is their first processor designed specifically for agentic AI. It delivers twice the efficiency and runs 50% faster than the previous Grace chip. Companies like Meta, Alibaba, CoreWeave, and Oracle are already lined up to deploy it. And the roadmap doesn't stop here. Jensen previewed the Feynman architecture, coming in 2028. Vera Rubin is the present. Feynman is the future.
Chapter 3. Dynamo, the operating system of AI factories. This one flew under the radar, but it might be the most important announcement for anyone actually building AI applications. NVIDIA launched Dynamo 1.0. It's open-source software that acts as what Jensen called the operating system of AI factories. Think of it this way. Running AI inference at scale isn't just about having powerful chips. It's about coordinating thousands of GPUs, managing memory, routing requests efficiently. That's what Dynamo does. In benchmarks, Dynamo improved inference performance on Blackwell GPUs by up to 7 times. 7x, with free open-source software. Now, I know a lot of you are here because you want to actually understand how AI is changing the tech landscape, not just read headlines. That's exactly what this channel is about. If this breakdown is saving you time, drop a like. It tells the algorithm to show this to more people like you. The adoption list reads like a who's who of AI. AWS, Microsoft Azure, Google Cloud, Oracle, AI companies like Cursor and Perplexity, payment companies like PayPal, social platforms like Pinterest. It's already being integrated everywhere. Why does this matter? Because it means the cost of running AI models is about to drop significantly. Cheaper inference means more AI applications become economically viable. The tools you use every day are about to get faster and cheaper.
Chapter 4. NVIDIA goes to space, literally. This was the moment that made the audience gasp. Jensen announced Space One, a rare Rubin module designed for orbital data centers. His quote, "Space computing, the ultimate frontier," has officially arrived. As we deploy satellite constellations and venture further into the universe, intelligence must exist wherever data is produced. The Space One module delivers 25 times more AI compute for space-based inference than the H100. It features the IGX door and Jetson Orin chips designed for size, weight, and power constraints. Partners include Axiom Space, StarCloud, and Planet. The engineering challenge? There's no convection in space, only radiation for cooling. Jensen acknowledged they're still working on it, but the ambition is clear. This isn't a gimmick. Satellite constellations produce massive amounts of data. Processing it in orbit instead of beaming it back to Earth saves bandwidth, reduces latency, and enables real-time AI decisions in space. Chapter 5. Physical AI and the Robot Revolution. The final theme was physical AI. NVIDIA's bet that AI is moving from screens into the real world. They announced partnerships with Fanuc, ABB Robotics, and Yaskawa for industrial AI. They previewed GR00T N2, a next-generation foundation model for humanoid robots that succeeds at new tasks in unseen environments more than twice as often as the best current models. They launched Isaac Lab 3.0 for robot training at scale, new Cosmos models for generating physics-accurate synthetic worlds, and an open physical AI data factory blueprint that companies like Uber, Samsung, Mercedes, and PepsiCo are already using. Jensen's vision is clear. He sees a future where every factory, every warehouse, every vehicle has AI that understands the physical world. Not just language, not just images, physics. This is a trillion-dollar vision, and NVIDIA is building every layer to make it happen. Chips, systems, software, agents, robots. So here's the bottom line. GTC 2026 wasn't just a product launch. It was a company saying, we're not just a chip maker anymore. We're building the infrastructure for the intelligence age, from data centers to orbit, from code to the physical world. And speaking of infrastructure, next week I'm breaking down the 3 AI models fighting to be #1 in 2026. Claude versus GPT 5.4 versus Gemini 3. That video is going to be a banger. Subscribe right now so it shows up in your feed. I publish every week, and I promise no clickbait, just the real numbers behind the biggest stories in AI. Hit the bell icon if you want to be the first to see it. See you next week.